After 56 years, humanity returns to the moon, but this time, we're staying. SpaceX plans to build Moonbase Alpha using Starship itself as the habitat. China and Russia just realized they're falling behind in a race they thought they were winning. The plan that changes everything. SpaceX's approach is radically different from traditional moon-based concepts. Instead of launching separate modules, assembling complex structures, and spending years building infrastructure piece by piece, SpaceX will use Starship itself as the base. The concept is elegant. Repurpose the vehicle's massive internal volume, particularly the empty fuel tanks after landing, into robust habitats. Starship's internal volume already exceeds the entire International Space Station. Converting its fuel tanks would add even more habitable space, potentially creating 2.5 times the ISS's volume in a single structure. The biggest advantage: this relies on existing technology with minimal modifications needed. 2 Starships will travel to the moon, one crewed, one carrying supplies. Both will rendezvous in Earth orbit for refueling before performing the trans-lunar injection burn. The landing site: Shackleton Crater at the lunar South Pole. The crater rim receives near-continuous sunlight while the interior remains in permanent shadow, creating cold traps where water ice has accumulated over billions of years, providing drinking water, breathable oxygen, and rocket fuel through electrolysis. The construction process: the vehicles will land at least 5 kilometers apart to prevent landing debris from damaging each other. After landing vertically, the real work begins: laying Starship on its side. This horizontal configuration makes modification into a moon base far more practical. A fleet of remotely operated robots will handle the transition. No need for astronauts in bulky EVA suits struggling with hand tools. The robots will prepare the terrain, clear rocks, level ground, and build 2 parallel berms of piled regolith on either side to stabilize the horizontal structure and prevent rolling. Once horizontal, remaining methane fuel is drained and stored. Internal pressure is maintained just high enough to preserve structural integrity without unnecessary mass. Then comes the transformation. Using specialized cutting tools, crews will cut openings in the fuel tank domes and install hatches, converting sealed tanks into accessible living spaces. Over several weeks, they'll unpack equipment and begin interior construction, installing insulation for thermal and radiation protection, building floors and walls throughout the tank sections, setting up life support systems and air circulation, running electrical wiring and communication systems, installing lighting and heat management systems, adding water tanks, plumbing, bathrooms, and showers, deploying an observation deck from the airlock facing Earth. The layout creates distinct zones: quiet sleeping quarters in one section, active work areas with labs and equipment in another, and storage, logistics in the converted tank sections. The final critical step: covering the entire structure with 3 meters of lunar regolith. This thick blanket of moon dust serves multiple purposes: shielding against micrometeorites — thousands hit the moon daily; insulating against extreme temperature swings, from minus 173 degrees Celsius at night to plus 127 degrees Celsius during the day; and providing radiation protection from cosmic rays and solar storms. Why China and Russia are worried. While China and Russia have spent years planning traditional lunar bases requiring assembly of multiple modules, SpaceX's approach leapfrogs that entire paradigm. China's lunar program relies on smaller landers carrying limited cargo. Their proposed base would require dozens of launches to establish basic infrastructure. Russia's plans, hampered by budget constraints and technological setbacks, trail even further behind. SpaceX's Starship can deliver 100+ tons to the lunar surface in a single flight, more cargo capacity than China or Russia could deliver in years of missions. More critically, the timeline advantage is staggering. SpaceX expects the first Moonbase Alpha construction to take 2 to 3 months after landing. Traditional approaches require years of sequential assembly missions. By the time China or Russia establish basic outposts, SpaceX could have multiple operational bases with permanent crews conducting advanced research and resource extraction. The economic implications are equally dramatic. Starship's reusability and payload capacity could reduce lunar access costs by orders of magnitude. potentially to $150,000 per person per day versus the ISS's $10 million per person per day. This cost advantage enables sustained operations impossible under traditional space agency budgets. The operational advantages. A Starship-based lunar habitat can comfortably support 12 to 20 astronauts for extended periods. The base enables critical activities: resource extraction, mining water ice from permanently shadowed craters, processing lunar regolith for oxygen extraction, and potentially harvesting helium-3 for future fusion reactors. Scientific research. Establishing astronomical observatories on the far side, protected from Earth's radio interference. Conducting geological surveys and studying long-term effects of lunar gravity on human physiology. Manufacturing, using lunar resources to produce building materials, testing in situ resource utilization (ISRU) technologies, and eventually building components for deeper space missions. Refueling operations. Converting lunar water into hydrogen and oxygen rocket propellant. Creating a refueling station for missions to Mars and beyond, dramatically reducing the fuel mass needed from Earth. Safety systems are extensive. Emergency exits every 250 meters, fire suppression with automated ventilation reversal, watertight doors capable of sealing flooded sections, and AI-monitored sensors tracking air quality and structural integrity. Scaling beyond the first base. SpaceX isn't stopping at one base. The plan calls for landing approximately 4 Starships per year, each customized for specific missions and upgraded based on lessons learned from previous deployments. Over time, this creates a network of specialized facilities around Shackleton Crater's rim, each optimized for different functions. Primary habitation modules for long-term crews, research laboratories for specialized experiments, manufacturing facilities for processing lunar materials, storage depots for fuel, equipment, and supplies, medical facilities with advanced life support. If Starship's landing legs can articulate, vehicles could be walked closer together after landing and connected with pressurized tunnels, creating an integrated lunar settlement. Elon Musk has already named this vision, Ota City. The long-term potential extends beyond simple bases. Musk envisions lunar factories producing satellites using robotic labor and lunar resources, then launching them via electromagnetic mass drivers, railguns taking advantage of the moon's low gravity and airless environment. With constant solar power and no atmospheric interference, lunar-manufactured satellites could revolutionize space-based AI computing and telecommunications. The geopolitical shift. This isn't just about exploration, it's about establishing strategic advantage in space. The nation or entity controlling permanent lunar infrastructure controls access to critical resources, water ice, rare minerals, helium-3, the best locations for astronomical research, refueling stations for deep space missions, manufacturing capability using local materials, the high ground for communications and observation. China's ambitious space program aimed to establish lunar presence by 2030. SpaceX could achieve operational bases by 2026 to 2027, establishing a multi-year head start. Russia, once a space superpower, finds itself unable to compete with SpaceX's rapid development pace and dramatically lower costs. Even NASA, SpaceX's primary partner and customer, is reconsidering its slower Artemis program timelines as SpaceX demonstrates what's possible with commercial innovation and aggressive development. Conclusion. SpaceX's Moonbase Alpha represents a fundamental paradigm shift in how humanity approaches space settlement. By repurposing Starship as habitat rather than building separate infrastructure, SpaceX eliminated years of development time and billions in costs. By leveraging reusability and massive payload capacity, they've made sustained lunar operations economically viable. By moving fast and iterating rapidly, they've created strategic advantages competitors cannot easily overcome. China and Russia now face an uncomfortable reality. The private American company they dismissed is establishing permanent presence on the moon before their government programs can complete initial planning phases. The new space race isn't about flags and footprints anymore. It's about who establishes the infrastructure, extracts the resources, and controls the strategic high ground. And right now, SpaceX is winning decisively. Moonbase Alpha isn't just the next step after Apollo, it's the foundation of humanity's expansion beyond Earth. The question isn't if it will succeed, The question is how quickly competitors can catch up.